For those of you that might not be too familiar with Bauder, it's a family-owned business. They're based over in Stuttgart in Germany. They've got daughter companies throughout Europe, one of the leading manufacturers of water heating systems throughout Europe and over in the UK. In the next 10 minutes, we're going to be looking in more detail at the cost of reinforced bitumen membranes in particular, because that's the more common choice for refurbishment works, and more specifically, what affects the price the most. And we're going to be focusing more on project complexity as well. But I mean, there are lots of things that affect the price, but we're going to be primarily looking at these 5 subjects: establishing the works on site, the preparation of the existing roof, so whether it needs to be stripped off completely, whether it needs a partial strip, whether it can be overlaid. The installation of the new roofing system comprises of the works provided by the roofing contractor to literally install the new roof. Then the other effect, of course, comes from the product and system differences. And also on top of that, there are some hidden considerations with regards to service offer, usually from the material supplier. So, quite delighted to run through this with you all. We're going to be looking at this project with 3 different perspectives. So we've taken a 400 square metre roof area, and in option 1, it has standard upstand details. So straightforward 150 millimetre upstands around the perimeter and around that central raised area. So when we look at the costing that's associated with that type of project, we split the preliminaries out, so the setup, scaffolding, that kind of thing, 14 days work, and then we're looking at the membrane costs, the insulation costs, and then the labour that's split into 2 sections, one for what we call the flat areas, but that's, we know flat roofs have falls on them, so that's really the horizontal area, and then the labour to install the details. Now, on top of those considerations, there are, of course, profits and overhead, and that will vary from contractor to contractor. But we're using the same formulation here across the board, just to demonstrate the different types of impact project complexity have. So on that project, the standard details, total costs 45,000, of which the material comes in at 21,000. So no need to remember these numbers. I'm going to summarise it after these few slides. So in option 2, we've got the same roof, but rather than having that straightforward detail around the perimeter, we've now got a 1,200 millimetre upstand that encapsulates the parapet wall. So it's up and across the top, probably going into a GRP roof edge trim. So what we refer to as complex detailing. Now, complex detailing has an impact on the cost because quite literally it takes longer to install that type of detailing. So it could be lots of plinths around the roofs. It doesn't necessarily mean it's just the perimeter zone. It could be plinths, could be awkwardly shaped details, complex details and scuff. There's all sorts of things add to this kind of complex nature on the details. The project takes longer, so the preliminary costs extend. The membranes are increased because you need more material, of course, to encapsulate these details. But the larger of the impacts is on the labour. It takes a lot longer to install a 1,200 millimetre upstand than it does a 150. So that has an impact on the overall cost, taking it up to £50,000, whereas the material has increased only by £1,000. I'm rounding these numbers off if you don't mind. So that's complex detailing, the impact that kind of situation has on that job. Now I'm going to take it to the next level and talk about option 3. It's the same roof. It has the same complex detailing, but now it's in a city centre environment. It's a restricted access project. It's what we refer to as a complex project. So the hoisting, for example, might not necessarily be able to be positioned on the outside of the building. It might need a crane to hoist the materials up. There are all sorts of things that make these complex projects. It could be littered with plant and equipment, that kind of nature. It has a dramatic effect on the price. So now, of course, we're extending the duration on site. So the preliminary charges go up. Interesting, the materials remain the same as before in option 2, but the labour to install the horizontal areas and also the big details in this complex nature mean that the price goes up significantly to £63,000, of which the material remains as option 2. So just to round this off, and the reason why I've chosen to use Powder Flex as the example here is because that's a middle of the road system that offers a 20-year guarantee. So it's kind of to benchmark off it in the industry at the moment. And you can see the impact that the complex job makes on the pricing. We can say hand on heart that the complexity affects it by as much as 40%. And honestly, it could be a lot more. I recently did a survey on a roof on a law court actually in Nottingham, where the roof was covered in plant. You could barely see the waterproofing. Now, to remove that kit to enable the works would be an extraordinary amount of money. But just these complex natures that we see quite often mean that we can see 40% increase, whereas the material cost on the same project increased by about 5%. So I suppose the message here is, if savings are required, then choosing to downgrade the quality of the products isn't going to offer you the kind of savings possibly that may be required. So it's a tricky scenario. Now, how important are the materials to you guys, girls, as specifiers? Well, I'd just like to take the next couple of minutes to explain why we feel the materials are so important. There are 3 scenarios there. Starting from left to right, we've got a 2mm, so these are the waterproofing systems above the insulation. We've got a 2mm underlay, and what they refer to as a 3 to 4mm cap sheet. Now, there's a bit of ambiguity there, because usually those materials are supplied by weight. It's difficult to know the exact thickness. So we'll come back to why the thickness is important in a moment, but it's usually between 3 and 4. The middle of the road range is in the middle. That's a 3mm underlay and a 4mm cap sheet. It works well on most all situations. And then you move into the top materials that are available in the UK with a 3.5mm underlay and a 5.2mm capping sheet. Why would you go for the thicker membranes over the lesser quality membranes? Because they offer the savings. Well, especially on complex projects, there's a rule of thumb. The more complex the situation, the more high quality the materials enable a really secure, robust result. And it's because you've got far more bitumen on those membranes. The bitumen that mixes between the top of the underlay and the underside of the capping sheet forms the performance of your roofing system going forward. And it is far more likely that the operatives will fully bond the thicker membranes in comparison to the thinner ones. And I'll tell you why. The thinner membranes are more difficult to heat up without marking the membrane. And that plays in the fixer's mind. So rather than making a mess of something, they tend to under-torch the materials so that it sticks in place rather than fully bonding in this molten modified bitumen across the full width of the membrane. And that can result in a regular adhesion. And what that means is you've got the potential of voids between the underlay and the cap sheet. So if there's a weakness in the side laps, the water can track through the system. And if that finds a weakness in the side lap on the underlay, then it can enter the insulation zone, and we've got big considerations. So those types of cheaper, low quality, thin membranes rely on the seal between the side lap rather than the performance of bonding the full width of the membrane. And that's really important, because on a complex job, the labour that's involved benefits from a membrane that's easier to install and is far more forgiving. And that's where the more durable, thicker membranes come in. Now, just to take this into reality for you, I've been scouting building sites and pulling things out of skips to bring this to you today. And on the left-hand side here, we can see this is the type of membrane that could be promoted in comparison with a more durable system with a similar in duration offer on the guarantee. Maybe hasn't got the comprehensive cover that we have on certain guarantees. But if you look at it closely, the top membrane is specified to be 5.2mm, and it was actually 5.3. And that alternative membrane wasn't specified as a thickness, it was a weight, but it was actually under 3mm, which even surprised me. So there is a big difference in the quality of the membranes that are out there. The other cost that's built in, of course, to materials that are hidden are these costs relating to the service. And this is the approved contractor installation, project monitoring by a team of site technicians. You might not get that with an alternative approach. The quality of the specification and the drawings and the design is fundamental to the factor of the contract and knowing what to do on site. So it's really important to get all that information in place. Has the system been certified? There are lots of costs associated with testing that you don't see. And then, of course, I've got these two final points to finish on. Energy loss estimates, where we can calculate how much defects are actually costing the building owner in loss of energy. And that's something that's growing. And moisture mapping surveys. And the reason why moisture mapping surveys are so important, they are a way of value engineering the project without compromising quality. We are talking here about identifying the roof, the area of the roof that needs to be taken off and replaced, and then replacing only that section. And it's great on the environment, not taking things to landfill. We've got the thermal improvements of the existing system as well as the new, and it reduces the cost to strip that roof off. So that's been a whirlwind tour. I'm going to hand over to my learned colleague now to explain more about moisture mapping. Over to you, Paul.
Thanks very much, John. Thanks very much for being here, everybody. It's exciting to deliver this next part of the Bauder seminar. So for those of you who do and do not know, Bauder provide a free site survey when we're asked to go on behalf of our clients. And this is particularly important for their clients in terms of how they're going to make strategic decisions with their assets. So we are used on a variety of different levels for immediate projects with immediate water ingress or problems, or for building surveyors on their professional works. So it could be the lapse, it could be to give to a service charge consultant, it could be it could be for a delapse or something along those lines. In terms of what we want to ascertain from our initial site survey is we want to look at the overall existing structural deck and its condition and the overall roof itself. So what better to start on the deck? We want to establish whether or not it's a fragile deck, what the nature of that deck is. Is it timber, metal, concrete? If it's a 60s or 70s build, are we dealing with hyaluronized cement? Is it wood wool? Is it a ceramic deck? Does it come under the realms of a deleterious material? From there, we want to establish what the actual waterproofing system is. Is it an overlay of the original? Is it original asphalt? Is it original pour and roll? Is it insulated or uninsulated? And from there, we want to take the condition of the insulation. Is it wet? Is it dry? Is there water under the cap sheet? Is there water underneath the VCL? These are all very, very important things to analyse as we go about our intrusive survey. Then we want to look at the falls. How are they formed within the deck? BS 6229 says that we should always have a positive fall on the roof. So is that formed in a screed? Is it formed in tapered insulation? Is it formed with tapered and firings? Or is it in the deck itself? Is it led to a fall? And then from where, obviously we're there to actually look at and assess the condition of the roof. Is there any defects? Is it degraded? Is there deflection in the deck? Is the screed failing? Is there moisture present with underneath the cap sheet? And if possible, are we able to identify what is causing those water ingress issues? So we're on site. We are now starting to do an intrusive survey. We take a core sample all the way down to deck level and through a screed if we can get there. From there, that will reveal and establish all the different layers, and then finding and analysing and recording those. So where is the water? Is there water present? Is there even a vapour barrier present? Because that would instantly tell you you'd have to strip the roof if there's no vapour barrier, because construction-wise it's not sound. From taking all that, we are now subconsciously starting to piece together what we are going to propose to the client. And then we would replace the sample after we've done our core, and we'd seal it as not to impair the integrity of the existing roof. From this, you can actually see a survey from one of my colleagues. It's only 5 pages of what would probably be a 58-page report. Chris Lawford is a former building surveyor himself, so he likes to go in about the actual bones of it. So we are led down 2 avenues once we have done our intrusive survey, whether it be to strip off or whether it be to overlay. Now, to strip it off, that would be either having a wet core sample, that would be water under the cap sheet, maybe the deck is in poor condition, maybe there's been multiple roof build-ups already. If that isn't the case, there's no trapped water, the roof deck is stable and it can take a new overlay, it's not something like Stramit or Failing Wood will, then we can look at overlaying that roof to try and save the client money, as John had alluded to earlier. But it's not always as simple as that. It's the most suitable course of action isn't always as clear cut as that. So we need to have some further investigation, and that's why we are delighted to next year offer the Troxler moisture mapping gauge, Troxler 3216, which is going to be supplementary to the comprehensive information that we already provide. So it's a moisture gauge, a nuclear gauge, which is very lightweight in nature, so it can be taken to pretty much 95–99% of our sites, and it uses both analog and digital readings, so we get a really accurate read every single time, so it's calibrated appropriately. So what are the benefits of actually using it? As John had mentioned earlier, it identifies so accurately where moisture is within a roof build-up. It'll highlight with pinpoint accuracy the areas that have to be replaced and stripped, or the areas that we can actually retain and overlay. So it's based on science in essence, so the results are extremely accurate, and the byproduct of using this to identify moisture is that it gives your clients a great way of saving unnecessary costs. In Scotland at the moment, everybody else does core samples, and that's the best and most accurate information we can give at this point in time. Not as of next year, we're going to have something more accurate than that. So the core samples and this report by the moisture gauge will be a comprehensive picture of your client's roof. So how does it actually work? It utilises the thermalisation of neutrons. To the layman, that's slowing the neutrons down. It provides readings on the gauge from depending on the construction type. It'll give you a reading, and then we plot that on a gridded sheet, which then will start to build a picture of what's wet and what's dry. It's important to say at this point that we carry out core samples at the end of the moisture mapping survey, and this allows us to establish a baseline. So we will see a pattern start to form as we're moisture mapping, and we will take anything which looks inordinately high, and then from there we will establish the baseline from dry, damp, wet up to saturated. So this is just a section of how it actually works in essence. So the moisture map emits fast moving neutrons, which are slowed down or thermalized by material. They're not slowed down, sorry. So basically the hydrogen has molecules within it, which act as a barrier to the fast moving neutrons. And if they're not present, then they can't revert them back to the gauge. Therefore, the reading would come back low, thus it's dry. If we experience, if we're on a damp roof, when the neutrons are emitted, there will be some partial molecules of hydrogen in there, which bounce back neutrons back to the gauge. The gauge will count how many neutrons come back to it, and from there it will give us another reading, and a medium reading will give us a damp reading. And then when something's extremely saturated, you can imagine the amount of molecules within the build-up will be pretty extensive. Therefore, the majority of the neutrons will be fired back to the reading, and that tells you that it's a high density of hydrogen within that build-up. So it's super accurate at finding hydrogen within the overall roof build-up. And you might be thinking to yourselves, I could have been doing this 12 months ago, but how do we get it going forward? So for us to carry out a moisture survey, the suitability would have to be over 200 square metres, and it has to be a warm roof scenario, has to be a warm roof, and it has to be a fairly even surface. So if it's a ballasted roof, then you would need to take that ballast off before we moisture map it. And also it can't be covered in water. So we go through the process like we did with any other condition report. So the moisture mapping, we grid it out in 2 metre squares, or we can mark it out with chalk, but we use the cones, and it's out in 2 metre sections, and we walk the roof, and once we walk the roof, we will start to record all the readings as we go. As you can see here in this bit of paper, we're noting down the numbers, and that will start to build the picture, and this is how it actually ends up. So once we are finished, we will produce a report for our client, and from that basis, we will either tell them to fully overlay based on something that you can see here. Everything's grey, so very low readings, only one area where it seems to be fairly high. A partial overlay where we cut out the defined sections, as you can see in this one here, there's certain areas which are filled with moisture, so we can cut them out and it can be accurately quantified, or something like this, which would tell you we would have to replace the entire roof structure, or the roof build-up. So basically, beyond that, you would have the condition report from ourselves, the initial condition report, and you would have the moisture gauge report. From that, you would have the most comprehensive and accurate information to save your client money and provide a precise scope of works in which to progress on. This here is just the Toyota manufacturing plant, which was 350,000 square metres, I believe, something in that area. We moisture mapped areas on that, and this is the result of that. So as of next year, we will have the most comprehensive and accurate moisture mapping and roofing surveying equipment available to you guys, which is going to be hands down the most beneficial to your clients.